much for your introduction. Let me start to say that Sebastian van Herk and myself and Bart van Buren, also being part of the Dutch team, are very privileged to be here. It's a great honor. Thank you very much for the kind invitation. Yesterday evening we had a discussion with Jiang about our presentation, so we changed a bit also the title of my presentation, but I think it's this is the one, yes. So my presentation is now a bit on climate adaptation and in fact the big challenge how to implement adaptation measures into practice. How do you move from a demonstration project towards mainstreaming in the bigger projects? So the key question is where are we and how can we really apply what we have learned and researched into practice, and are those demonstration projects the vehicles to do that? Sorry for this. Okay, but first this picture, maybe I showed it last year as well. In the audience, you are part of this research team of TAICA, isn't it? Yes. You all are part of the research team. Okay. So this map shows where we are in Taiwan, and the other dot is the Netherlands, and there are some statistics comparing the surface area, the population, and the density. And what you see, and that's, I think, is quite striking, that those two countries have a lot similar in size and density, but there are also, of course, differences. But I think it's very interesting to see that that they are quite similar in some aspects. And what is maybe interesting for this context is that your country is a country where you have a very harsh environment with, say, extreme events and a highly dynamic natural environment. Whereas as we look at the Netherlands, it's in a delta. It's at the end of large river systems. So when there is a river discharge, a flood wave coming from the hinterland, we know it quite some time ahead. It is a very slowly responding system. So I think that's a bit different between the Netherlands and Taiwan. So this is a typical picture, the mills, and the mills, of course, they were there because they were used to pump the water out to the sea. So it was being used to reclaim our land, and as you know that a large proportion of our land is reclaimed land and is below sea level. It's 66% is below sea level and needs to be protected by dikes and levee systems. Now, that's not the same as Taiwan, because you have a large proportion living on elevated terrains, you have mountains, and the situation is a bit different. But what is also interesting that a large part of our economic assets are in those low-lying parts, so there is a chance that they will be impacted by a flood. And we talk about a very low probability, high impact situation. And that means when you talk about a very low probability and a high impact, that people are often not aware about the risk. When you have a very low probability, the risk awareness is quite low. So we have a quite low risk awareness. Okay, I think that's enough for the time being. And another issue which is relevant, and that's about our governance. Have you heard about the polder model? Is poldering a term which you are using? Now, poldering is a Dutch term which is now also being, I would say, internalized in other places, and it stands for seeking the consensus. In the Netherlands, we have a very rich culture of negotiating. Everybody should be on board, and that stems from the times we had a lot of water boards managing our water system. So we had a few hundred water boards, and it was needed to engage the stakeholders and engage the higher governments to take decisions. So the poldering and looking for consensus is a typical Dutch, I would say, culture or tradition. And that means often that at the end, when a decision has been taken, that nobody is at the end very happy. Because everybody has to, I would say, pay his own part. But I think that is important that we have a very, say, a system of multi-level governance, a system where we negotiate. And also a very important aspect is that we would like to emphasize that what can be dealt on a local, regional scale should be dealt there, but only when we need a higher level of governance to make decisions, we will take those into account. But so there's a strong, I would say, tendency to seek for local commitment and local decisions. Okay, this is a bit the wider theme of flood risk, climate adaptation and climate change. What you have to know that in Europe, there is, if you look at the statistics, most research papers on the impact of climate change in Europe, they show that there is no significant impact discernible. We cannot see from the data, if we correct for autonomous growth, that there is any significant impact of climate change yet. But that is, you can say, that is at this very moment. But on the longer term, it is expected that climate change will have a large impact on the risk of flooding. So that is, I would say, a very important thing. And the risk of flooding, climate change is impacting the probability, and of course, due to economic growth, the impact itself is increasing, so the overall risk is increasing by two factors: the factor of climate change impacting the probability, and the factor of economic growth impacting the impact. Now, what is important if we look at climate change and climate change adaptation? There is a lack of what we call uptake of innovations. There is a lot of research being done in Europe. I will come to that later. A lot of money being spent on climate research. But where are the innovations, and where are the innovations really getting implemented? So there is a really concern about that. And there's another thing which is also, I would say, gaining interest, is the international collaboration. And the international collaboration is needed to create, I would say, an extra impetus to knowledge exchange. We call it accelerated learning. And we need to learn from each other. Globally, floods are on the rise. A lot of countries have similar problems. So it makes a lot of sense to learn from each other and to, in fact, facilitate the process of networking. And Sebastian will touch upon that issue later. By the way, if you look at climate change adaptation in Europe, most cities in Europe, and that's more than 20%, has an adaptation plan or an adaptation strategy. And I think that is also something which is relevant for the discussion here, that most European cities has an adaptation strategies. If you look at adaptation, if you have a strategy, then the next step is, of course, to implement the strategy, which for a large part means also implement measures and changing the system. Now, if we look at how we are performing in Europe, then we have to conclude that it is quite complicated to really get to implementation. We lack the tools and frameworks. Just as you mentioned, TICAT is also putting emphasis on getting better frameworks to support the governments, the local governments. Financial aspects are very relevant, as Sebastian was just emphasizing. The cost benefits are very relevant, and most governments are complaining that they say, okay, we have to invest in climate adaptation, but tell me, what are the exact costs and what are the exact benefits, and when do I have to implement? So there are a lot of questions surrounding this issue, and that makes decision making quite difficult. Now, and then there are also questions about, okay, we have demonstration projects. We have in our Dutch program the hotspot demonstration project, but how do we scale up? Because a demonstration project is not only to test tools, but it's also to use to catalyze other areas and for upscaling. So how do we upscale? What are the vehicles to do that? And I'm sure that also Sebastian will elaborate a bit on that more. Okay, I think that's enough for the time being. This is a conference which will be held in September 2014, and I already submitted a proposal for Taika to give a presentation on that conference. It's pending. It's perhaps maybe one of the professors who are very invited to take part in this conference. And this is a closure conference of the national program Knowledge for Climate. It's a quite similar program as TICAT, but it's almost completed. And the whole objective of this conference is on practice. So the issue is we have done a lot of research, a lot of demonstration projects. Where are we now? And did we really deliver in what we promised to deliver, and how do we really impact the practice? This is an overview. This is the Netherlands, by the way, and here you see a lot of projects everywhere, demonstration projects, measurements, games. Now you can go, it's an interactive website, you can go to that website and you can click on those icons, and then you get the tools or the information which is dealing with all those, I would say, climate adaptation projects of the Climate Knowledge for Climate program. Now, this was a very brief introduction. I will now go to the three-point approach as a tool, as a communication tool. It was already emphasized that you are also looking for communication tools. This is one tool which has been developed in MIRA Asia, in MIRA project, in our European project. It's a Dutch invention, so I will briefly share it with you, and maybe it's not new, maybe it's new, I don't know, but we can discuss this later on. And then I would like to elaborate a bit more on the EU research programs, and where are we now, what have the bigger research programs on climate change and flood risk, what's the legacy of those programs, and where do we go to, and are there opportunities for you, for this university to participate. And then I would like to conclude with some conclusions. So the three-point approach. And the three-point approach is a very simple approach. It is about a communication tool. And when we have to decide upon a measure, to implement an adaptation measure, then the three-point approach says that there are three aspects you should take into account when considering implementation. And you see here, this graph, you have, for instance, the return period, and you have the costs and impacts along this axis. Now, we have a threshold here where we can say, okay, when that method or when that measurement or that intervention has been implemented, the objective is to reduce the impact of climate change. So we have a threshold. So in the conventional world, the engineers were the ones who make the design of the intervention, for instance, a dike system or a stormwater system, and they optimize the design according to a standard. So this is the domain of the engineers. But apart from the domain of the engineers, there are other aspects which should be taken into account as well. Another aspect is, okay, when the system will fail because the flood wave is higher than expected, higher than the design level, so we should take into account that there are exceedance events. So every measurement, every adaptation measure be implemented should also be regarded in the sense that how does it impact when we speak about an exceedance event? What are the impacts? So this is more the domain of planners, but also engineers, but also planners, urban planners, notably. And then we have the day-to-day event. When we build a levee system or we build a stormwater system, only 1% of the time, or even less, it has its real function to return the water or to drain the water, but 99% of the time it is there. So we need to think also what is the added value, what is the day-to-day events contribution of the system. So the three-point approach is in fact embracing the idea that we should include not only the engineering aspects of a measurement, but also the situation where the system will fail, as well as how the system is contributing to the day-to-day situation. So I have captured this, summarized this in those three text bullets. So we have the domain of the technical optimization, we have the domain of exceedance, and we have the domain of daily values. To make it a bit more complicated, when we look at the point 2 where we talk about the standardized events, there are two approaches which we can embrace. The traditional approach, when we start with a climate scenario, and then we say, okay, we have a climate scenario, it generates pressures, it impacts the state of the system, and at the end we need to respond. So that is the traditional top-down approach. What is now gaining more interest is an approach where we say, okay, those climate scenarios, we are quite uncertain about those climate scenarios. We have no exact clue what is the rate of, for instance, sea level change, sea level rise. So are we able to decouple the scenarios, which are always linked to a time frame, and the impact? So the new approach, we call it the tipping point approach, is doing the reverse and starts from bottom up. So what is it doing? It said, okay, we have a system. How much can the system tolerate? How much pressure can the system tolerate? And then if we have identified when the system will exceed its standards, then we can say, okay, then we have to respond. So this is what we say the top-down approach. And I have one example to make it a bit maybe more complicated. But this is one of the first tipping point assessments. Tipping point has been done for the Thames in the UK. And here you see we have the pressure here. There is no scenario. They only speak about rising sea level. And then we have here the existing system, that's the Thames barrier in the UK. Now, they can say, okay, the Thames barrier, it can cope with about another 50 centimeters of sea level rise. And when that's being surpassed, we have to change to another system. We have to implement another system. So these are different routes. There are, in this scheme, 4 routes which could lead to the management of the Thames estuary using different systems, applying the tipping point approach. Now, at the end, when this scheme has been delivered, the next phase could be, okay, when we see that a critical phase will be achieved around this sea level rise, when could that be? When could that momentum in time be? So at the last stage, the real scenarios, climate scenarios, will be used to assess when the interventions are needed. But this system is in fact decoupled from an absolute time scale, and that makes, I would say, communication about what is really needed a much more easier. If you talk about this was the second point, the point of standardized events, where we can use the method, the traditional top-down method, as well as the bottom-up measure. This is about point 3. When we have designed an urban area, in this case along a river system, we could also take into account when the levees are being are breaching or when the system is becoming flooded. Now this area, this is in the city of Dordrecht, and you can see here that this area has been designed in such a way that it can cope with exceedance events. So, when we talk about the 3 points approach, point 2 and point 3, this is the domain of what we call flood resilience. Flood resilience is capturing standardized events, but also when the system fails. But there's another domain, that's the domain of the livability, which is in fact spanning between those 3 layers and also capturing the day-to-day event. Now I have some events, I will quickly go through them. This is the sun of the city of the sun in Heerhugowaard. It's one of our, this is a new area in the northern part of the Netherlands. It's situated in a big lake, and that lake is being there because it is also a lake to store stormwater. Now, this is a very nice example where those 3 domains are being taken together, because it is a unique example of how different functions can be combined. One is water storage, there is water retention in this area. Those homes are partly designed to cope with 1 meter fluctuating water table, and it has a very high quality of life. This is a closer image of some of the homes you can see there. These are the green roofs of that city. And this is another city in Seoul. You may know this. This is one of the big examples, success stories, where you see where they have reintroduced the old river system. And this old river system has a dual function. It prevents heat island effect. The average reduction in temperature rise is about 5 degrees Celsius. But apart from an adaptation measure, this is also adding a quality to the city. This is another example. This is in Rotterdam, where we have a dike system, a very new dike system, which is in the same time a green roof and a park. So you can see the combination of, say, those different options from the 3-point approach are coming here together. And this is a water square, quite famous in Rotterdam. It's meant, of course, to collect storm water, but it's also a playground for children, and you can see here that even in wintertime you can skate. I think this is ideal for Taiwan. I don't know whether you have ice in winter.
No.
I thought already, but it was a joke, but nobody was laughing. Okay, so that was a bit an introduction on climate adaptation and where we are at this moment, and the need for integration and the need to capture also the quality of life. Now about the EU flood research and the EU research on climate change. We have in the European Commission framework programs, and they started in the early 80s and they are still going on. Those programs are financing research, not only for European research entities, but sometimes also for entities abroad, outside Europe. And if we look at the research in flood risk, climate change, they started in 1984, and the first programs were directed to understand the system, to assess the problem, and to see, in fact, what are the impacts of climate change, what are the impacts of floods. Around 2005, 2007, there was a new phase where the Commission was more inclined to know more about, okay, we know what is the problem, but how should we manage the problem? So the projects, the framework programs in that stage were more directed to have a better understanding about managing the problem. Now, in that period, from 80s up to now, the whole thinking of how to manage flood risk, of climate adaptation changed a bit. We went through two transitions. One transition is that we started from managing the probability to see that we should not manage the probability, but we should manage the risk. It's not only the probability, but also the impact. So there was a shift from what we say, from flood defense to flood risk. Later on, in that phase, when we had an understanding about the flood risk, there were also a lot of researchers who were advocating the view that we are not so certain about estimating the probabilities as well as the impact. There are large uncertainties around those probabilities and impact, as was already emphasized by you. So, in fact, the idea that we could predict and control nature and that flood risk management systems could, say, safeguard our countries, that was a bit disputed. And so we moved on to, say, a new way of thinking where we say, okay, we are less certain about our risk-based approach. We should more embrace the uncertainty-based approach, and that goes along with an adaptive management regime, another governance regime. Now, this is in a very short elaboration. What is the tendency and the trends in European research? But what we see now is that we thought we had managed we have now say enough research on managing the problem, and these are the big flagship programs in the FP7, FP6 and FP7 directed to understand how we should manage the flood. We are now moving to Horizon 2020, and what came across is that, okay, we have now a better understanding how to manage the problem, but there are still a lot of open questions. And one of the open questions is the integration. How should it be linked to the other domains? Flood risk is important, climate change is important, but there are other aspects which are for those who are in the governance are probably much more important than climate change and flood risk. So there is a very strong emphasis in the new programs to have, say, to also capture the other challenges, to go beyond demonstration. How can we really scale up demonstration projects? And also to have, say, to seek the international collaboration. Okay, to conclude a bit what I told in my presentation, what we see is there is a call for integration. Integration in the sense that flood risk and climate change are interesting, but it should be combined, taken into consideration with other major drivers like the economic driver and the energy drivers. So there's a call for integration between domains, but there's also a call for integration, what we could say, between different stages in projects. Learning, active learning culture, and accelerated learning. And Sebastian will elaborate on that. We also see that widespread uptake is hampered. It has to do with the lack of integration. We have to harmonize objectives. The Learning and Action Alliance is a vehicle to overcome these problems and to have a better, I would say, alignment with the stakeholders' needs and to have a better integration. And last but not least, there are opportunities for international collaboration as well to achieve that accelerated learning. Okay, that was my presentation. Thank you. Are there questions, or shall we wait for the questions after Sebastian's presentation?